So here are the explanations for the Activate math questions for week 2. Question 1 goes back to some of the information that was discussed last week about types of numbers. So which is not a rational number? A rational number is one that can be written as a fraction. This also includes a terminating or a repeating decimal. So this is a rational number. The square root of 3 cannot be written as a fraction or as a repeating decimal or a terminating decimal. So that is the one that is not rational. But just to kind of walk you through the others, the square root of 9 is equal to 3. So again, that is rational. It can be written as a fraction. 17%, if you take the meaning of the word percent, you can write that as 17 out of 100 or 17 over 100. Since that can be written as a fraction, that is a rational number. 8/10 is rational. So G is the correct answer. The square root of 3 is not a rational number. On number 2, you're given BC is tangent to circle O at that point C, and the measure of arc AC is 73 degrees. And you're to find the measure of angle OBC. Okay, so a couple of things that you need to notice. This is the diameter of circle O. So a circle is 360 degrees. So therefore this portion of the circle would be 180 degrees. Well, since we know 73 degrees is already used, the remaining arc, this arc DC, we could find that measure by doing 180 minus 73. So the measure of this arc, DC, would be 107 degrees. And the two segments that connect to create the angle we're trying to find the measure for, they are a tangent segment and a secant segment. It just happens to be a diameter of the circle. So to find the measure of that angle, what you're going to have to do, the measure of angle OBC is equal to half the difference of the measure of the intercepted arcs. So the larger arc is the 107, the smaller arc is the 73. So you'll subtract those and then take half. So that's half of 34 degrees, and half of 34 degrees is 17 degrees, which is answer choice J. The next question deals with simplifying radical expressions. So you could do this problem a couple of different ways. What I would do first would be to focus on this 20, because 20 is the product of 4, which is a perfect square, and the number 5. So if I'm simplifying, the 12 stays outside. And then instead of taking the square root of 20, I'm going to take the square root of 4 times 5. So the square root of 4 is 2. So that's going to come outside of the radical, and we'll multiply that by the 12 that was already there. We don't know what the square root of 5 is. That is not a perfect square, so we'll leave the square root of 5 underneath that radical, and we'll deal with the square root of 6 momentarily. So at this point, we've got 24 square root of 5 over square root of 6. So what we're going to do next is called rationalizing the denominator. We don't typically leave radicals in the denominators of fractions. So to get rid of that, we're going to do what we call rationalizing the denominator. So I'm going to multiply both the numerator and the denominator by the square root of 6. So really this number here is just 1. It's a funny looking 1, but it is just the number 1. So when we do that, In the numerator, we've got 24 that's going to stay outside of the radical, and the square root of 5 times the square root of 6 is going to be the square root of 30. In the denominator, we've got the square root of 6 times the square root of 6, so that's going to be the square root of 36. So as we continue to simplify, 24. Now, 30 does not have any perfect square factors, so we'll leave the square root of 30. We know that the square root of 36 is just 6 because 36 is a perfect square. Then we can reduce the 24 and the 6. So 24 over 6, or 24 divided by 6, is just 4. And then the square root of 30 remains. Therefore, our answer choice is letter A. In the next problem, parallelogram ABCD has measure of angle A 60 degrees. AB is 6. BC is 10. And you're to find the area of the parallelogram. So to find the area of a parallelogram, we'll multiply the base times the height. And remember, with a parallelogram, opposite sides are both parallel and congruent. So the base of the parallelogram is equal to 10. The height would be the perpendicular distance between the top and bottom, or between the two bases. So the triangle that's been formed there is actually a 30, 60, 90 degree triangle. And it's at this point that those special triangle rules will really help you out. We've got the hypotenuse labeled here as 6. When you're looking at a 30, 60, 90 degree triangle, the short leg of the triangle, which would be here across from 30 degrees, is equal to half the hypotenuse. So that short leg is equal to 3. The long leg is the leg that's across from the 60 degree angle. And if you're using your 30, 60, 90 rules, the long leg is equal to square root of 3 times the short leg. So our height for that parallelogram is 3 square root of 3. So then the area for that parallelogram would simply be 30 times the square root of 3, which is answer choice D. So it would probably be a good idea for you to review the rules for special right triangles before taking the ACT. And then on number 5, you've got the diagram, you've got a circle where BE is 2, and you've got CE, which is 3, and then you have DE, which is 6. You're trying to find AE, so we'll call that X. So when you have two chords that intersect within a circle, the product of the individual segments of those chords will be equal to each other. So, for example, when you take the two portions of this segment and multiply those together, so that would be 2 times 6, that will end up being equal to the matching portions of the other chord. So you've got the portion that's labeled X and the portion that's labeled 3. So 2 times 6 will be equal to 3 times X, or 3X. Again, the product of the two portions of each of the chords will be equal to each other. So that means 12 will be equal to 3X. And if you divide both sides of the equation by 3, that means X will be 4. So our answer choice is letter F. So another thing that might be wise to review would be the relationships among the angles and among the segments that you can construct both inside and outside of circles.